Hello everyone, my name is Jie Li. I am from University College London and I am glad to present our paper on anatomy of multipath BGP deployment in a large ISP network. This work is conducted in collaboration with Lancaster University. The background of our paper is multipath routing. There have been some old assumptions in this area. For example, there is only one single IP level path between a pair of hosts, and if different paths were observed, they were very likely to be caused by measurement errors or misconfigurations or routing dynamics. However, in recent years, there have been a number of researches on multipath routing. These researches were carried out to detect multipath based on MDA with active traceroute probing, or on path diversity, or on MPLS with existing traceroute datasets. All of these researches have proved that multipath routing could be a legitimate means to achieve load balancing for ASs. Our paper studies the multipath BGP deployment. At first, we need to know what is multipath BGP. Multipath BGP is a technique that allows a router to learn and install multiple equally good paths to the same prefix from the same neighbor AS. These multiple equally good paths have equal values for the first 6 attributes of the BGP decision process. So far, some major router vendors have supported multipath BGP in their routers. In this area, there have limited number of researches, and one of them discussed the motivation to apply multipath BGP and proposed some alternatives to multipath BGP. Basically, we lack insights to the level of multipath BGP deployment in the Internet. Therefore, our paper contributes as the first research work on measuring multipath BGP deployment and illuminating the crucial aspects of multipath BGP. The contributions of our paper are in 3 aspects. The first contribution is we proposed a method to identify MBGP, and the method is based on looking at server data. Our second contribution is that we study the deployment of MBGP on a large network, which is Hurricane Electric. This network has thousands of peering ASs and hundreds of border routers. This provides us sufficient information on its MBGP deployment. Our third contribution is that we carried out traceroute measurement to reveal more details on MBGP deployment. We have identified 2 types of MBGP deployment, and all of the cases involve IXPs. Our method relies on data from LG server. There are 2 reasons. The first one is that the existing border mapping methods can be inaccurate. And the second reason is LG server data provide ground truth on AS borders and MBGP deployment. The direct information we use to identify MBGP is from the response to the command show IP BGP route detail. This picture shows an example response to the command at this router. This is a border router belonging to Hurricane Electric. We can see that this border router has installed 2 paths to this network, and both paths have the same values for these attributes. Both paths are labeled as M and E, which means they are multipath and they are learned via external BGP. This information fulfill the condition of MBGP deployment. So we can say that Hurricane Electric has deployed MBGP at this border router with this peering AS. Our method is used on Hurricane Electric. According to the latest Canada's AS rank data, it ranks number 7 and it has more than 8,000 peering ASs. It has 112 border routers. These border routers are distributed around the globe. Our methods to identify MBGP consists of two steps. The first step is to use Show IP BGP summary to get a list of peering ASs at each border router. This picture shows an example response to the command. We can see that among the peering ASs, these three ASs are connected to Hurricane Electric via multiple neighbor addresses. With data from PeeringDB, we know that all these IPs belong to IXPs. With this command, we have obtained 5,868 peering ASs at all border routers. And among these peering ASs, 1,309 are connected to Hurricane Electric via multiple neighbor addresses, and 4,622 are connected via IXPs. In the next step, we will focus on peering ASs that are connected to Hurricane Electric via multiple neighbor addresses and via IXPs. In step 2, we use Show IP BGP route detail to query the first IP address in each /24 prefix obtained from route views for each peering AS. We use /24 prefixes because they account for around 60% in the BGP routing table. The aim of our paper is to find evidence of MBGP deployment, so we don't consider all the prefixes obtained from BGP routing table. And note that our query to each peering AS stops once MBGP is identified for prefix. This indicates that not all of the prefixes are queried in our method. We identified 950 cases of MBGP deployment, and this picture shows the number of peering ASs and the number of peering ASs via IXP and the peering ASs with MBGP deployment for each border router. We can see that at most border routers, most peering ASs are connected to MBGP via IXP. Among the 112 border routers, 58 border routers are identified with MBGP. And we can see that Paris 2 and Stockholm 1 are identified with MBGP deployment to 75 ASs, while there are 8 border routers being deployed with MBGP to only 1 AS. The 950 cases of MBGP are deployed with 512 peering ASs. This picture plots for each of the peering ASs their number of border routers with MBGP deployment. These peering ASs are ordered by their customer cone sizes. We can see that the low-rank ASs are more likely to be deployed with MBGP at multiple border routers. And among these peering ASs, Yahoo is deployed with MBGP at 30 border routers, and 407 ASs are deployed with MBGP at only 1 border router. We then deployed traceroute measurement on right packets to obtain more details of MBGP deployments. The chosen sources are geographically close to border routers of San Jose 2 and Toronto 1. And for the destinations, we use the IP addresses belonging in each prefix with identification of MBGP deployment. The traceroute lasted 4 days in February 2020, and the other settings are all default by RIPE Atlas. After obtaining traceroute data, we need to do IP2AS mapping. Here, we use the agreed mapping results between border mappage and RIPE-STAT API. For those IP addresses belonging to IXP, we map them to farside aliases, which are the peering aliases of Hurricane Electric. From the traceroute data, we identified two types of MBGP deployment. The first type is called parallel type. This figure shows the topology map of an example in this type. We can see that the traffic enters the near-side border router San Jose 2 via two near-side IPs, and then the traffic enters the IXP of Equinix San Jose via two IXP IPs with equal probabilities. Then the traffic is forwarded to one link between IXP and farside border router from each IXP IP, and the traffic is forwarded with equal probabilities. We can see that between the IXP IPs and the farside IPs, there is no cross, so this type is categorized as parallel type. We plotted the routing graph for this example, and from this figure we can see that each IXP IP is used for half of the traffic to the destination IPs, and the choice of IXP IP for each destination IP is permanent in our traceroute measurement. The second type of MBGP deployment is called divergent type. This figure shows the topology map of an example in this type. We can see that the traffic again enters the near-side border router San Jose 2 via two near-side IPs, and then it enters the IXP of Equinix San Jose via two IXP IPs with almost equal probabilities. Different from the parallel type, the traffic from each IXP IP is forwarded to multiple links between the IXP and the farside border router. The traffic from each IXP IP is forwarded with similar probabilities. We also plotted the routing map for this example. Again, from the figure we can see that each IXP IP is used for half of the traffic to the destination IPs, and the choice of IXP IP is permanent for each destination IP in our traceroute measurement. In conclusion, our paper reports the widely deployed MBGP by Hurricane Electric. All of the identified MBGP cases involve IXP interconnections. Hurricane Electric is a large ISP network, and it proves to be an ideal case to understand the MBGP deployment in the Internet. The results in this paper is based on queries to a limited number of prefixes. This provides a lower bound of Hurricane Electric's MBGP deployments. We have been applying our methods to a wider range of ASs. The preliminary findings show that MBGP can be deployed via direct peering or even on single interdomain link. Thank you for your attention. We are open to any questions and comments.